Welcome back to yet another installment of Dave Does Calculus from Home. Today we should be wrapping up section 9.3 differential equations with our fourth installment of the videos for this section. If you have not seen the first three, you should watch those first. This is just going to be a quick wrap up where we do one last example, going through all the different steps. So without further ado, I'm going to get started on that. The example that I want to do is 3y prime equals y times the cosine of 5x. And this problem has an initial condition. It is y of 0 equals 1. So this is going to be a full example. We're going to work with this to find a general solution. Then we're going to plug in our initial condition to get a particular solution. Then we're going to verify our answer. So, as always, I start by transforming this y prime into a dy looks like my independent variables in x. So I'll turn this into a dy dx. Y times cosine of 5x. Now I need to separate these into y's and x's. So I'll put the y down here. 3 dy over y. I'll put the dx over here. Cosine of 5x dx. Now this is completely separated. All my y's are on the left, all my x's are on the right. I can just take some antiderivatives. The antiderivative of 3 dy over y should be 3 natural logs of y. This antiderivative of cosine 5x should be the sine 5x over 5 plus c. And this, after we have taken our antiderivatives, this is the implicit general solution, which is not at all what I want. I want an explicit particular solution, so we're going to keep going. I need to divide both sides by 3. That'll give me the natural log of y equals the sine of 5x over 15 plus some other constant. Again, when you do arithmetic to this constant, it will become a different constant, probably whatever the first one was divided by 3. Don't care. I'm just going to label it as a different constant, and it's still just as arbitrary. This process of just sort of not really tracking what you do to a c value because it stays an arbitrary constant, this process works right up until you solve for c. The point at which you put these numbers into here and get a value for c, that's the point where it does start to matter what you do to c. If you change it after that point, you have to change that actual number. But until we actually put in this value and solve for it, it's arbitrary, it can be anything. So, one more step here. I need to see what happens. This is the problem. I'll underline that. I need to get rid of the natural log by taking both sides as exponents on top of e. So this is e raised to the sine of 5x over 15 plus c2. And as we have done in previous videos, this addition inside the exponent can be split into two exponents, e to the sine 5x over 15 times e to the c2. And e to the c2 is just yet another arbitrary constant. So I'll call that c3, e to the sine of 5x over 15. This is now an explicit general solution. It's explicit because I've solved for y. It's no longer implicit where stuff is happening to y. It's explicit now. Y is by itself. Still general because I have a constant. I haven't yet solved for the constant. I need to solve for the constant, so I'm going to do that right now. I can just plug these values in. This is a y value, this is an x value. Just plug them in, see what happens to your constant. So y is 1 equals C3 times e to the sine of 0 over 15. At this point, everyone remembers that the sine of 0 is just 0. 0 over 15 is still just 0. E to the 0 is 1. So this is 1 equals C3 times 1. So C3 just equals 1. So I now have the information I need to write a particular solution. I still have to actually write that solution. I'll try to squeeze that into this corner. This was my general solution here. Gen solution. So I need to rewrite this general solution but use this value for c instead of some mystery constant. So I'll say y equals, if it's being multiplied by 1, I can actually just sort of skip that. I'll just say e to the sine of 5x over 15. This is my particular solution. So that's the process, start to finish, of finding a particular solution. Oh, did this get... It got zoomed. This wasn't supposed to be zoomed. That's weird. Okay, now we can see all of the edges of the board. There's still one thing left to do. We need to verify that this solution is in fact a correct and valid solution to this differential equation. And to do that, I'm going to erase a bunch of stuff so that I have room. Okay, if y equals e to the sine of 5x over 15, this is the particular solution that I'm checking to make sure that it works. The first thing I need to do to this particular solution is I need to know what y prime is. Y prime is going to be the derivative of e to something. The derivative of e to something is e to that thing times the derivative of the inside. The derivative of sine 5x over 15 should be cosine 5x over 15 times the derivative of the inside of this, which is 5. So this is a double chain rule sort of event. I'm skipping the inside-outside steps here with the blobs because that's Calc 1 stuff, and hopefully we've got a pretty good handle on that. If not, feel free to pause the video and work it out. Pretty sure this is correct. So this is, I think, y prime, and I can simplify this just a little bit. I'm going to call this the 15 and the 5. In fact, actually, let's do this. If this is y prime, what I'm really interested in is 3y prime. So I'll put the 3 on both sides of this. Just multiply both sides of this thing by 3. So that this side of the equation is 3y prime, which is what I want to be working with anyway. Once I include that 3 here, the 5 and the 3 will cancel out this 15 entirely, and I will just be left with e to the sine of 5x over 15 times the cosine of 5x. So this is me taking the derivative and multiplying it by 3. I need to compare this to y times the cosine of 5x. That's on this other side of the equation. So y times the cosine of 5x should look like e to the sine 5x over 15 times the cosine of 5x. This is y, this is times cosine of 5x. And these things match. So my solution is verified. That's it for today. That's it for pretty much this entire section. We're solving differential equations by separating them out, taking some antiderivatives to get a implicit general solution. Solve that for y to make it explicit. You can solve for c using an initial condition to make it particular. And then you can check your answer using derivative rules and substitution. That's an entire differential equations problem. See you next time.